The t-statistic and the student t-distribution. The t-statistic testing the mean. Consider the t-statistic used to test the hypothesis that the mean of big Y is mu sub big Y naught using data big Y sub 1 through big Y sub n. The formula for this statistic is given by equation 3.10, where the standard error of big Y bar is given by equation 3.8. Substitution of the latter expression into the former yields the formula for the t-statistic. T equals big Y bar minus mu sub big Y naught over the square root of S sub big Y squared over n, equation 3.22, where S sub big Y squared is given in equation 3.7. As discussed in section 3.2, under general conditions, the t-statistic has a standard normal distribution if the sample size is large and the null hypothesis is true. See equation 3.12. Although the standard normal approximation to the t-statistic is reliable for a wide range of distributions if big Y of big Y if n is large, and it can be unreliable if n is small. The exact distribution of the t-statistic depends on the distribution of big Y, and it can be very complicated. There is, however, one special case in which the exact distribution of the t-statistic is relatively simple. If big Y sub 1 through big Y sub n are independently and identically distributed, draws from a normal distribution, then the t-statistic in equation 3.22 has a student t-distribution with n minus 1 degrees of freedom. The mathematics behind this result is provided in section 18.4 and 19.4. If the population distribution is normally distributed, then critical values from the student t-distribution can be used to perform hypothesis tests and to construct confidence intervals. As an example, consider a hypothetical problem in which t superscript act equals 2.15 and n equals 8, so that the degrees of freedom is n minus 1 equals 7. From appendix table 2, the 5% two-sided critical value for the t sub 7 distribution is 2.36. Because the t-statistic is smaller in absolute value than the critical value, open 2.15 is less than 2.36, close, the null hypothesis would not be rejected at the 5% significance level against the two-sided alternative. The 95% confidence interval for mu sub big Y constructed using the t sub 7 distribution would be big Y bar plus or minus 2.36 standard error of big Y bar. This confidence interval is wider than the confidence interval constructed using the standard normal critical value of 1.96. The t-statistic testing differences of means. The t-statistic testing the difference of two means given in equation 3.20 does not have a student t-distribution, even if the population distribution of big Y is normal. The student t-distribution does not apply here because the variance estimates are used to compare the standard error in equation 3.19 does not produce a denominator in the t-statistic with a chi-squared distribution.